All right, welcome to this lesson about reflections. So we always reflect in a line in mathematics. When that happens, one of two things is going to go on. First of all, usually your point is not on the line of reflection. So here point A would reflect in the line to become A prime. This reflection happens perpendicularly to the line of reflection, and A and A prime will be the same distance away from the line of reflection. This is going to be another congruence transformation, so when we reflect objects, they'll be the same shape and size, but an important note here is that the orientation will be reversed. I'll get into more on that later. Now, less common is when the point is actually lying on the line of reflection. It will not move at all, so it's just going to stay put, such as in this case. So in this problem, we're going to be reflecting each of the points in the x-axis. Just really quick, here's my x-axis. So this is my line of reflection. On the notes previously, that would have been line K. Now, I'm going to take each point and reflect it in that line. So where A is at 1, 1, it will now be at 1, negative 1. So here will be A prime. Now, I'm going to go ahead and make a note of that over here as well, that it is now 1, negative 1. This is how you would answer using a Google form for me when you're doing your assignment. Also, you can remember that if you're reflecting in the x-axis, all that's going to happen is your y value is going to get negated. So where I have B is 3, 2, I know that B prime is going to be 3, negative 2, without even needing to reference the graph over here. But if I go 2 units away, another 2 units away, here is B prime. Now for C, since it is at 4, negative 1, again, you negate your y value, so C prime is going to be at 4, positive 1. The x value does not change. And for D prime, 2, negative 3 will become 2, positive 3. And we can just connect this in to make our image. But if you're submitting work to me through a Google form, this is what I'm after over here. I don't need to be seeing your graph. All right, very well. So reflecting in the y-axis is similarly easy. It's actually the same figure here as we had on the previous example. So when I'm reflecting in the y-axis, I'm just actually going to negate each of the x values I see. So A prime, negate the x value, will become negative 1, 1. Because since it's 1 unit away from the y-axis, 1 unit to the other side. So here will be my A prime. So B prime from 3, 2 will become negative 3, 2. And don't forget, if the x value is already negative, all you'll have to do there is just make it positive to negate it. So here is B prime. C is 4, negative 1. So it's going to become C prime is negative 4, negative 1. You can see I'm leaving the y value alone on each of these. And you can do this on the graph if you like. I think it's just easier just to look at what the coordinate is and just adjust it as I need it to be. And then D prime, since D is 2, negative 3, negative 2, negative 3. So here's my new image. All right, you can see on both of these problems, these images are congruent to what they originally were, so they've not been changed. Though the orientation has been reversed on each of these. So where it was going clockwise, A, B, C, D, now it's going counterclockwise, A, B, C, D. That's the only difference between these two, outside of their location as well. All right, on this next to last example, we're going to be reflecting in the line x equals 1. I've already got that graphed right here. Remember, x equals, those are vertical lines, so that's x equals 1, this would be x equals 2, and x equals 3, and so forth. Y equals is horizontal lines, don't forget. You can always graph it on Desmos if you want to give yourself a quick check on that. So now, there's no real quick rule here. It's actually a glide reflection is what it ends up being. But we're not going to get into all that. Really just count the blocks over and see where you got to move to. So going to go perpendicular here with M. So, and then it's 1 unit away. So I'm going to go 1 unit to the other side. So where it was 0, 1, M will now be 2, 1. M prime 2, 1. Really, I probably should have started with J and K and then L and M, so I'm doing this a little out of order, forgive me. Now I'll go on and do L. I'll just do it in reverse order. All right, so L, I've got to go to the left in order to reflect it in my line of reflection. So it's 1 unit away, so 1 unit to the other side, 0, negative 1. So L prime is 0, negative 1. It was 2, negative 1. All right, now I'll go to K prime. So here's K. I'm going to travel directly to this line of reflection. It's 2 units away, 2 units to the other side. Here is my K prime. And that's at negative 1, 2. And my last one, which should have been my first had I done this correctly, is J. So it's 1 unit away from the line of reflection, so 1 unit to the other side, 0, 3. J prime. And I can connect those. Again, congruent transformation, because my new figure is actually the same size and shape as my original. All right, this is perhaps the trickiest, but honestly the most important, is when you're reflecting in y equals x, because it comes up time and again in our class. Now, first of all, the line y equals x is a diagonal line with a slope of 1 that goes through the origin. So this right here, this blue line I've put in, is my line of reflection. That is y equals x. If ever they ask you to do y equals negative x, it still goes through the origin, just it's going to be going down from left to right because the slope would be negative 1. Now I'm going to reflect every single point. Let's start with point A. Point A is actually on the line of reflection, so it's going to stay at 1, 1. So that point is A prime. Now I'm going to go on to point B. Now B is a half diagonal away from the line of reflection, so I'm going to go another half diagonal away. So B prime is actually at the location 2, 3. Now if you look back at what B was, it was 3, 2, it became 2, 3. This is just a simple swap of x and y is all we're doing, which makes sense since we're reflecting in the line y equals x, x becomes y becomes x. The only reason why that actually did happen for point A, because 1, 1 swapped places to be 1, 1. All right, now moving on to C, and I'll show you how easy this can be. Ooh, I rhymed. And so 4, negative 1 will be negative 1, 4. So it's way easier if you approach the problem like that. So negative 1, 1, 2, 3, 4, a lot easier than actually trying to count how many diagonal units it is away and stuff like that. Just swapping x and y is the way to go. There is a rule for it that x, y becomes yx, described as a rule. Lastly, we got D, and for D, since it is at 2, negative 3, it'll become negative 3, 2. Again, just swapping x and y. And I forgot to be labeling these, so I'm going to go back and do that and just connect them in really quick to make sure the image looks correct compared to the original, the parent image. And it does look pretty good. All right, folks, that wraps up this lesson. Look on the Google Classroom to know what your assignment is. Thanks.